Good afternoon. My name is Lane Harper, or the Diesel Doctor.
On a common rail system, you might find that you'll get an injector that gets stuck wide open. How you know that this is happening is you're going to see some white smoke coming out of your exhaust tailpipe. When you see that, stop the vehicle, because if you keep going, that's what could happen right here.
Yes, and this causes the engine to fail. You will need an engine overhaul when this happens. This will happen within 20 miles of this white smoke starting to come out the exhaust. It's caused by the fuel injector injecting fuel on anywhere where the piston is located, whether it's up, down, under compression stroke, exhaust stroke, no matter what. And so this is very important when you're driving a newer diesel engine, that if you see large quantity of white smoke, stop now, not 20 miles down the road.
The injector ran wide open, and then pretty much it just tears the piston to pieces. That Dodge right out there, that's
which is this engine right here,
this engine right here,
has this condition. This is why it's out of the truck, and this is the engine that's going to go back in. And this also happened to this engine, but this engine has now been rebuilt.
So what's it supposed to look like? That?
Oh,
Jeez, they're heavy.
Yeah.
Oh my gosh!
I
had no idea that was that heavy.
I can show you a lot of heavier ones. Yeah.
Okay.
Yeah. This is just a small diesel. This is what the top of the piston should look like. No damage at all whatsoever. Even though this piston probably got maybe close to 600,000 to 700,000 miles on it. Piston should like this, but as I say, this engine here maybe only had 150,000 miles on it, but it has suffered from catastrophic damage from an injector sticking into the full fuel position. To replace an injector, we're talking Canadian terms, approximately $1,000 will replace an injector. To rebuild an engine and to get an engine replaced, you're looking at anywhere from, let's say, $14,000 to $20,000.
That's a big difference.
Much different. So
you see that white smoke?
That white smoke, we shut it down. Now we'll go back again to the basics of the engine. We were talking about when the piston was up here, the fuel is injected. That fuel then will push the piston down, and that's your power stroke that puts the power to the rear wheels. Then both valves are now closed when that happens. When the piston gets to the bottom, the exhaust valve opens, the piston comes back up, and it pushes the exhaust out through the exhaust manifold. Now, modern engines use what they call turbocharger. Now, a turbocharger is one of the few things in life that gives you something for basically nothing. You have exhaust coming out that is going to waste. So therefore, when it comes out, it turns a wheel inside this component at extremely high speeds. Speeds could be as high as 140,000 revolutions per minute. These ones here turn approximately 80,000 revolutions per minute. This is an exhaust side. This is the oil supply. There's a bearing in here, and on this end is a compressor wheel, which compresses the intake air, which comes through your air filter going into here. It compresses it maybe as high as 40 to 50 psi. This air then comes out of this part of the turbocharger, goes through a cooler up front, either called an intercooler or an aftercooler, and then it goes around to this side of the intake. Now, a fine example of that engine that we just had in here called an N14. That engine was first developed in 1926 and sold as 81 horsepower. When the last one was built in 2003, it produced 525 horsepower, but it was the same size engine. So that gives you some idea the evolution of that particular engine. But they had to stop production of it in 2002 because it would not meet emissions. So now they have that engine is obsolete. They went to what they call an N14 to what they call now an ISX, which is a 15-liter engine, and it is, let's just say, not one of my favorite engines. The N14 is my favorite engine of all engines to work on. It's easy to work on and it's very easily fixable, but now the ISX is much, much more complicated and more prone to failure. So, this is, again, the B-Series Cummins that's used in the Dodge pickups or the Dodge Rams, which is, and also many other applications, small Freightliners, the Ford F650, F750, Peterbilt trucks, small Peterbilt trucks, used in a lot of city delivery trucks. It is controlled what they call, with it, as I mentioned before, an ECM, and that's, as you see, many multitude of wires that go up to it, and a fuel pump that produces the 28,000 psi. The common rail over here, fuel goes in, and you have like these wires here go to the injectors to control the injectors. And there's sensors on the fuel filter here, and there's sensors on the turbocharger over here. There's a sensor here that's hooked up to the turbocharger, and we have also this goes on this engine here. There's a sensor here that, if you see the missing tooth here, when that missing tooth goes over to here, it picks up a signal, and that tells the engine that the piston, number one piston, is now at top dead center. And the camshaft has a sensor in back here that picks up a signal from the back of the camshaft. If you see the back of the camshaft here, gear has one blank spot. This is essential to start the engine, because that puts the engine in the proper position to start. And once it starts, then the ECM figures out that every so many degrees of rotation is going to give ignition to the fuel. And because that is a common fuel pressure, the fuel pump does nothing but delivers fuel to the injector, and the injector is electrically controlled. Now, on the rear of the engine, you have, depending again, if it's a standard shift transmission, you have what's called a flywheel, which is a steel plate with a clutch bolts onto. On an automatic, you have what they call a flex plate, which is this, and the torque converter bolts to it. And on the rear, also, and you also have what they call a ring gear, which the starter engages to start. Now, the purpose of this flywheel or flex plate, not only does it have makes provision for the starter to be mounted on, also the engine has to have something to keep the momentum going between each ignition, because it's 120 degrees, because the engine has to turn twice to get full two revolutions of the crankshaft in order to run. So you've got to have something, a mass, to keep that engine running 120 degrees before the next ignition comes up. Now again, this is basics of all engines. And on the 6-cylinder, it's 120 degrees. On a V8, of course, it's less. You have engines in this world that has many as 20 cylinders. So instead of 120 degrees between fire and order, you have you do the math, ignition is much, much less. Anyway, but that is the purpose of a flywheel or torque converter. Besides, the torque converter also drives the automatic transmission, but the mass of the torque converter or the mass of the flywheel keeps the engine rotating.